Hello everyone, I welcome you all for another session on bending moment and shear force diagrams, module 3 of mechanics of materials. So the problem which I intend to solve has been written there, please go through carefully here. Okay, you may wonder there are no supports, okay, so it is not that. Carefully observe, the supports have been replaced by the reactions whatever they offer. So one support is at A, the other support is at B, and those supports probably are roller supports. That is why you have only vertical force at A and D, and I shall name them and say this is what is RA and say this is what is RB. So A and D are the supports that you have. And what type of loads you have? You have two types of loads. One is uniformly distributed load, the other one is point load. Okay, point force and uniformly distributed force. Okay, two each in number. So point loads 30 kilonewton and 40 kilonewton, and the uniformly distributed loads 10 kilonewton per meter and 20 kilonewton per meter. Okay, so please spend some time and observe. And what type of beam is it? It is an overhanging beam, and overhanging is only one side, and that too on only right hand side overhanging beam. Okay, so as usual, so before I decide what is the reference, etc., first let me complete the reactions. I would like to find out reactions. Okay, so the first step, what is called as reactions. I want to find out the reactions. For the sake of finding out reactions, I shall draw one more diagram where I shall replace all UDLs by point loads. Okay, so say this is RA, then this is 2 meters in between, this is 2 meters, this is A and this is B, and this is where I have what is called as a point load, 30 kilonewton. And between this A and B I have UDL. So how much is the load? 10 multiplied by the length, 10 kilonewton per meter, multiplied by 2 meters, that is 20 kilonewton. 20 kilonewton is acting at the center of this. This is 20 kilonewton. This is equivalent point load replacing this UDL. Okay, so what is this distance? From here to here is 1 meter, and this distance is also 1 meter. Okay, then proceed further. Then you have another 2 meters. So this is where you have C, and C again you have what is called as a point load, 40 kilonewton. You have plenty of loads. Okay, 40 kilonewton C, and then you have another 2 meters, another 2 meters. This is where you have a reaction which you are supposed to find out. This is what is RB. Then you have another 2 meters, and this is what is point E. And between C and E, you have a UDL. UDL is how much? UDL is how much? That is 20 kilonewton multiplied by how much length? 20 kilonewton per meter. 2 plus 2, 20 into 4, 80 kilonewton. The load is 80 kilonewton. That is UDL. Where is it acting? It is acting at the midpoint of that. This is 4 meters, half of that 2 meters, and therefore it is this point. It is this point that this 80 kilonewton is acting. Okay, please remember this kind of diagram I make it only to find out reactions. Okay, so once I start bending moment, shear force analysis, then I shall go back to this diagram. Please do not continue this as your final beam, and don't draw the bending moment shear force diagram for this. If you draw it, then you will end up with the wrong result. It is only for calculating reactions. Okay, so now total upward force, how much is that? RA plus RB is equal to the total downward force, which is equal to 20 plus 30 plus 40 plus 80. 20 plus 30 plus 40 plus 80. This is 70, 170 kilonewton. Therefore, the total this thing is 170. Now, I would like to find out. I would like to find out the RA. So, therefore, sigma m above D is equal to 0. Okay, you can choose any other point also, but you have to either choose A or D. They are the only. If you take about B or C or E, then what happens? Then both the moments will be there and the required equation you will not get. And then otherwise you will get one more equation in terms of RA and RD and this also. Then solve them simultaneously, then you may get it. Okay? So to make one of the moment 0, either due to RA or RD, then you choose either moment about A or D. I am taking about D so that RD will not be there in my expression. Okay, so let's start with this. RA multiplied by what is this? From here to here, 2 into 6. So when I write this, unknowingly I have already decided what is the sign convention of my moment. So RA into D, this RA into this 6 meters, I have written it positive. That means clockwise moment is positive. Okay, then 20 into this, it will form anti-clockwise moment, therefore it is minus. 20 into what? This is 1 meter, 1 plus 2 plus 2 into 5. 20 into 5. This 30, this also will form anti-clockwise. 30 multiplied by 2 plus 2, 4. The next 40, that also is minus 40 into 2. Okay, proceed further. RD and this 80 kilonewton, they will not produce any moment. Then the thing else, that the whole thing is equal to 0. So therefore, RA is equal to something divided by 6. So what is that? 20 into 5, 100. 30 into 4, 120, 40 into 2, 80, 200, 300 divided by 6, this is 50 kilonewton. RA is equal to 50 kilonewton, therefore RD is equal to how much? RD is equal to 120 kilonewton. Therefore, go back and write out what is RA. RA is how much? RA is 50. And what is RD? RD is 120 kilonewton. Okay? So now we are ready to start. So what is the first thing? Choose the reference. So choose the reference. What is your reference? What the reference you are choosing? So it is always the end of the beam, either one of the ends, either A or E. You can choose either A or E. I shall choose A as a reference. Choose A as a reference. Okay, fine. Then what are the portions you have to analyze? Portions for analysis, portions for taking sections. So what are the different portions? So one is the portion AB, between A and B. Okay. Then the other one is B and C. The portion B and C. And then the other one is C and D. So though you have only one node here between up to E, but there is one node here that is 120 kilonewton upwards reaction is there at D. Therefore, you are forced to take one more section between C and D. And then finally come what are the D and E. So more the sections, more the time it is going to take, nothing else. Okay? So but it is very mechanical and therefore, so if you have more sections, it will take more time. Have patience. This is your highly reliable question from the examination point of view. So you can't afford to make mistakes in this. So therefore, let me start with what is called as what is that? Portion AB. Let me start portion AB. Okay, draw the free body diagram. Okay, take a section between A and B. So So my x is going to be, I'm going to write up here. So it is A and B. Section E is between A and B. So this is A and this is my reaction 50 kilonewton. And I have got as medium. This is 10 kilonewton per meter. And this is where I have cut it. And this is at a distance of x. Please remember, this is not B. You have to take section between B and E. Between B and A. What is the smallest value of x? X is 0. And what is the largest value? It is 2 meters. So between 0 and 2 meters it is valid. And therefore, what is the shear force? Positive shear force as per our sign convention. I have taken section here. For my analysis, I am taking the left hand side portion. Therefore, the shear force positive is downwards. It will be x. And my bending moment, positive bending moment is this. Okay? So this is Vx and Mx. Once you draw this, show this, then it is very simple. First, apply the equilibrium conditions. Resultant force equal to 0. When you start writing the resultant force equal to 0, I always start with Vx. So that means the downward force is positive. Okay, the downward. Then this 10 kilonewton per meter, that force is downwards, therefore it is plus. So how much is that? It is 10 multiplied by x. So this length is x, 10 kilonewton per meter multiplied by length, that is x. Okay, then 50 kilonewton, it is upwards, therefore it is minus 50, therefore this is equal to 0. Therefore Vx is equal to minus 10x plus 50. Minus 10x plus 50, that means, what is your observation? Shear force is not constant between A and B. Shear force is varying between A and B. Shear force varies linearly or according to a straight line. So straight line, the moment you identify what is shear force at A, shear force at B, and join them to get in between. So shear force at A, for that x is 0, that means it is 50 kilonewton, it is plus. And shear force at B, for that x is 2. So minus 10 into 2, minus 20 plus 50, this is 30. 30 kilonewton. So very simple, complete it. So shear force at A is plus 50. This is 50 kilonewton. And at B, it is 30. Little more than half of it. So write this as 30 kilonewton, and in between it is as per this relation. Okay, this is what is the shear force. Similarly, I would like to get the bending moment here itself for this. Let me start with mx, fine, mx. Okay, so then this 10 kilonewton. So please remember, unknowingly I have made the sign convention. What is that? This is my positive. What is this? Anti-clockwise is positive. The moment due to 10 kilonewton per meter about this section, this also is anti-clockwise. Therefore, this also is plus. So then how much is the length? 10. I hope I don't have to draw a separate point load, all that. So 10 into x, this is the load. If you have any doubt, you can immediately do that. This is what is, this is 10x, this distance is x by 2. Okay, 10x into x by 2, this is the moment. Okay, so then moment due to this 50 is opposite, therefore it is minus 50 multiplied by x is equal to 0. So therefore, mx is equal to, write 50x minus 1 to 5. This is 5 times x square. 50x minus 5 times x square. Okay, therefore bending moment is not constant. Bending moment varies. So how is the variation? You have x raised to 1, this is alright. But you have x raised to 2. So the variation is non-linear, or the variation is a curve. The bending moment between A and B is a curve. I hope you understand. If it is a curve, then I don't know how the curve is. Let me get at least bending moment at A, bending moment at B, and bending moment maybe at x is equal to say 1 meter, that is in between. Let me find out. Okay, so bending moment at A, substitute x equal to 0, the bending moment is 0. Bending moment at B, that means x is equal to 2, that's 50 into 2, 100, minus 5 into 2 raised to 2. 2 raised to 2 is 4, 4 into 5 is 20, so this makes 80 kilonewton meter. And bending moment at x equal to 1, substitute x equal to 1, this is 50 and minus 5, this is 45 kilonewton meter. Forty kilonewton meter. No, sorry. 50 into 1 is 50, minus 5 into 1 square. 1 square is 1, that's 5. 50 minus 5 is 45. 45 kilonewton meter. So therefore, draw it. Okay. So at this end it is 0, the bending moment, and at B it is plus 80. So this is 80 kilonewton meter, and at A it is 45. Please remember, this is 80, it is more than half. This is more than half. So this value is 45. 45 kilonewton, not per, it is meter, kilonewton meter, 45. Okay, so now it is going. So I don't know what is it. So I have 3 points. I have different options. Join this. So let me show it here. Okay. So I have 1 point here. This is 1, and this is the. Okay, this length and this length. This length is more than half. Okay. So the different options. So it is not going to be the concave in shape because this length is more than half, therefore it may be like this, or will it go up and then start decreasing? I don't know. So I don't know how is the variation of this. Okay, therefore I can say that mx is equal to, okay, how the shape of, I just want to know whether the maximum value occurs in between this. So here it is 45, here it is 80, and I am not sure whether this bending moment is more than 80 in between. So is it possible it goes like this and it may come back like this? No. So therefore, to check that what I do is I differentiate dmx divided by dx. Just to find out, recall how to find out the maximum and minimum value of a function. So dmx by dx is equal to 50 minus 5 into differentiation of x square, that is 2x, and equal to 0. So this is equal to 50 is equal to 5 into 2, that is 10x. So that means x is equal to 50 divided by 10, 5 meters. So that means x is 5 meters and our range is only 2 meters. That means this maxima occurs beyond A and B, and therefore this x is not relevant for us. Not relevant for us. Because our range of x is between 0 and 2 only. So what it means is the curve is like this. This is the shape of the curve. Okay. So now, the bending moment diagram also is over. Okay. Portion AB is over. The same thing, similar thing. What we have to repeat. So it is only operations, as I keep telling. I have nothing else to teach. Whatever I have, I already have told you. Now go for what is called as portion portion BC, portion BC, portion BC. Okay, portion BC. Draw the free body diagram. So I have what is A, then I have what is called as B. Okay, C is not there, and this distance is 50, and this distance is X, and this distance is 2 meters, and this distance is X minus 2 meters, and this is 30 kilonewton, and I have UDL, this is 10 kilonewton per meter. Lot of notes are there. Okay, 50 and this 30 kilonewton. This is where I have cut it. I have shear force, what is called as Vx, and I have what is called as the bending moment, what is Mx. Okay, so now all the things have been shown, and let me write down what is the range of X. What is the range of X? What is the smallest? Please remember, it is the meaning of this. The section has to be between B and C. The section is measured from, or it is stated, where is it? With respect to A. That is what we call it as X. So the smallest value of X can be 2 meters and the largest value is 4 meters, so that it can be between B and C. So now with this start, so Vx downwards positive. Okay, then 30 kilonewton downwards, therefore it is plus 30. Then this 10 kilonewton over a length of 2 meters, 10 into 2, 20 downwards, therefore positive 20. Then next, this 50 upwards minus 50, the whole thing is 0. So this is equal to, the shear force is equal to 0. The shear force between B and C is 0. So shear force is 0. So therefore shear force here, it doesn't vary, there is no question of variation, it is 0 only. So shear force 0 indicates this is the shear force diagram. Shear force does not vary, shear force is constant, shear force is 0 between the portion B and C. Okay, let me go for Mx. The bending moment Mx. This is Mx, anti-clockwise positive. Then the load, because the moment because of this 30, that also is anti-clockwise, therefore it is plus 30 multiplied by this distance, X minus 2. Then the next one, because of this 10 kilonewton per meter, 10 kilonewton per meter, what is the load? What is the load? So first direction, this side direction, the load is downwards, therefore the moment is anti-clockwise, therefore it is plus. Then how much is force? It is 10 kilonewton multiplied by 2 meters. 10 kilonewton per meter spread over 2 meters. How much is the force? That is 10 into 2. So where that 20 is imagined to act, it is acting at the midpoint of this portion. It is this load. So what is this distance? This is 1. And how much it is? X minus 2. 1 plus x minus 2, that is nothing but x minus 1. Or you know that this also is 1, this is x minus 1. So therefore 10 into 2, x minus 1. By chance, if you have any difficulty here for writing this, please draw this diagram once again, replacing the UDL by point load. You will get the same thing. Okay, then this is over. Then this 50, it is minus 50 multiplied by x. This is equal to 0. Therefore, mx is equal to okay, minus 30 into x minus 2. Minus 20 into x minus 1 plus 50x. Okay, what is your observation? Bending moment is not constant because of the presence of x. Bending moment varies. And go to the power, check the power of x everywhere. X raised to 1, x raised to 1, x raised to 1. What does it indicate? The bending moment varies linearly. It is a straight line variation. So for straight line variation, 2 points sufficient. The bending moment at B and bending moment at C. So for B, x value is 2. Substitute x equal to 2. This term is 0. The first term is 0. X equal to 2. 2 minus 1. 1. 1 into minus 20. This is minus 20. Then x is equal to 2. 50 into 200 plus 100. 100 minus 20 is 80 kilonewton meter. Similarly, bending moment at C. For that, substitute x equal to 4. 4 minus 30 into 4 minus 2. 4 minus 2 is 2. 2 into 30 minus 60. 4 minus 1 is 3. 3 into 20 again 60. 50 into 4 200. Okay, 200 minus 60 and minus 60. This is 80 kilonewton meter. Wonderful. Okay. So 80 kilonewton bending moment at B, correct now? It is a straight line variation. Bending moment at B is 80 kilonewton per meter. Bending moment at C also is 80 kilonewton per meter. 80 kilonewton per meter. And this also is 80 kilonewton per meter. Okay. So how does it vary in between? It is a straight line. Here also 80, here also 80. This is 80 kilonewton per meter. Not per meter, 80 kilonewton meter. Okay, any substitution mistake? Just check it. X is equal to 4. 4 minus 2 is 2. 2 into minus 30, minus 60. 4 minus 1 is 3. 3 into minus 20, 60. And 50 into 4, 200. Okay, so I hope you got it. Then go for. Yes, I'll continue for one more question and then go for, and I shall write for CD, and again as usual and like last time I shall give homework for the portion D and E. Okay, so quickly I have shortage of time. So take the portion CD. Portion CD, draw the free body diagram. Okay, you have A, then you have B, then you have C. Okay, D is not there. This is where your section. This is what is your X, and you have what as 50 kilonewton. At B you have 30 kilonewton, and you have in between what as 10 kilonewton per meter. Then at C you have about 40 kilonewton. Then here also you have UDM, what as 20 kilonewton per meter. Okay. In addition, what else? I have the shear force Vx, and I have what is called as Mx. Okay, let me write down quickly. So before that, what is the range of X? X is the smallest value is 4 meters and the largest value is 6 meters. 4 and okay, Vx start with this downward positive, and before that I shall write down this is 2 meters and this also is 2 meters. And what is this distance from here to here? This is x minus 4. This is x, this is 2, this is 2, x minus 4 meters. Okay, Vx. Then let me take this. The force is downwards, therefore it is positive. Then 20 multiplied by the length of this portion. What is the length of this portion? X minus 4. 20 into x minus 4. Okay. Then this 40. That also is downwards. 40. Then next this 30 downwards positive 30. Then next, because of this 10 kilonewton per meter which is spread over 2 meters, it is downwards, therefore it is positive. How much? It is 10 into 2. Then 50 upwards minus 50. The whole thing is equal to 0. So therefore 3x is equal to this term minus 20 into x minus 4 minus 40. Let me add this. 40 plus 30, 70. 70 plus 20, 90. 90 minus 50, 40. It goes to the other side, minus 40. So many kilonewton. So shear force is not constant. Shear force varies between C and D. And shear force variation is a straight line because of x. Shear force at C. Substitute x is equal to 4. So 4 minus 4, 0, it is minus 40. Shear force at C is 40 kilonewton, minus 40. And shear force at D, what is that? X is equal to 6. 6 minus 4 is 2. 2 into minus 20 is minus 40. And another minus 40. This is minus 80 kilonewton. Okay, shear force at C is minus 40. So this is 40 kilonewton and shear force at D is minus 80. So this is 80 kilonewton and the variation in between is a straight line. This is the shear. Okay, so on the same lines, what is the bending moment? Mx starting with mx. Okay, so if at all you are not comfortable with UDL, replace it by equivalent point load. Okay, so Lx, this Vx will not have. Then I shall write the moment due to this. First of all, it is downwards, and about this, it is anti-clockwise, therefore it is positive. Then how much is the load? Load is 20 multiplied by the distance. The distance is x minus 4. So 20 into x minus 4 is the equivalent load which is acting at the midpoint of this. And what is this distance? That is x minus 4 divided by 2. So what is the distance? X minus 4 divided by 2. So proceed further. Then you have 40. That also is positive. Plus 40 multiplied by x minus 4. Okay, proceed further. 30. That also is plus 30 multiplied by from here to here. That is nothing but x minus 2. 30 into x minus 2. Proceed further. Then because of this 10, that also is plus first of all 10 multiplied by 2. This is the load multiplied by the distance. The 10 into 2 is the equivalent load which is acting at the midpoint. From here to here is x minus 1. Then proceed further. You have another load that is minus 15 multiplied by x is equal to 0. Very mechanical. Okay, so 2 1s are 2 10s are. So your bending moment expression Mx is equal to minus 10 into x minus 4 whole square. Then minus 40 into x minus 4 minus 30 into x minus 2 minus 20 into x minus 1 plus 15 times x. Okay, so observe carefully. So here, because of the presence of x, the first observation, bending moment is not constant between C and D. Bending moment varies. What is the variation? Don't jump to the conclusion that x raised to 1, x raised to 1, x raised to 1, x raised to 1. Here x raised to 1, fine, but you have one more raise. X raised to 1, that raised to 2. That means you will have x square term. And therefore it is a curve. the variation of bending moment between C and D is a curve. Between C and D is a curve. Please remember that. Okay. Then if it is a curve, then what is the bending moment at C? Bending moment at D and bending moment at X is equal to in between. What is that? 4 and 6. That is 5. So all these three. And this is a curve. I have so many terms X terms are there. I also want to know where the bending moment is maximum. So between 4 meters and 6 meters, the bending moment where it is maximum, for that I need to find out or differentiate what is called as dmx upon dx, differentiating and equate it to 0. So this is equal to minus 10 into differentiation of x minus 4 raised to 2. That is nothing but 2 into x minus 4 into 1. Differentiation of x is 1. Minus 14 into differentiation of x minus 4. You are differentiating with respect to x only and therefore it is 1. Then minus 30 into differentiation of x minus 2 with respect to 1, that is nothing but 1. Then minus 20 into x minus 1, that is 1. 20 into 1 plus 50. 50 into differentiation of x, that is nothing but 1. So simplify this. This is minus 20 into x minus 4, minus 20 to x minus 4, minus 40, minus 30, minus 70, minus 90, minus 90 plus 50, minus 90 plus 50 is minus 40. Am I right? 20 plus 30, 50. 50 cancels, yes, minus 40. So this is equal to 0. Therefore, 20 into x minus 4. Okay, I shall take this to this is equal to minus 40. 20 into x minus 4 is equal to minus 40. That means x minus 4 is equal to minus 40 divided by 20. So this is equal to minus 2. And therefore x is equal to this. Minus 4 goes to the other side. This is 4 minus 2. This is equal to 2 meters. That means the maxima or minima occurs when x is equal to 2 meters. What is your x range? It is 4 and x. Therefore, irrelevant. This value of, that means you are not going to have the peak value, the maximum value between 4 and 6. Irrelevant. I hope you have found out now bending moment at point C, that is x equal to 4, substitute that, and at D you substitute 120 plus or minus plus 120 kilonewton. At D minus 40 kilonewton per meter. At 5. Okay, let me find at C. At C it is 120 plus this AD and one more, some more. This is 120 at C. Then at D it is minus 40. 40. And at x equal to 5, is it positive or negative? One more in between. Minus 26. It is minus 26. 20. Exactly half of this. 20. This is 40. This is 20. Therefore, oh, sorry. And on the same lines as usual, I shall give you the last portion between D and E as a homework for you. I hope you will be able to do it. If you have any doubt, definitely we are there and we will help you. What can happen now?